What's up everyone, I'm Nic Raboy from MongoDB. In this tutorial, we're going to see how to use Atlas Search. More specifically, we're going to see how to compound multiple search operators into a single operation. So let's paint a picture. Let's say that we want to search for restaurants. We want to provide some kind of text criteria, whether that be the type of food that we're searching for or the name of the restaurant, but we don't want to return every restaurant that possibly exists in our database. So what we're going to do is we're going to compound our search to also use geospatial operators. So specifically, we're going to be using geoWithin. So using the two in a compound way, we can not only search for certain text, but we can also search within a certain geographical area as well. So this is going to be similar to a previous tutorial that I had created where we had entered text into an HTML input field and it returned possible search results as we were typing. The exception here is instead of just typing in text, we're also going to be working off of location data as well. So up on my screen, you'll notice that I do have MongoDB Atlas. We will need it for this particular tutorial. And we're also going to be using Node.js and the MongoDB Node.js driver. So within MongoDB Atlas, let's go ahead and look at our collections. You'll notice that I have several sample databases within my cluster. We're going to be using the sample database sample Airbnb. If you haven't already installed these sample databases, you can do so from the MongoDB Atlas dashboard. But we're not going to get into that for this particular tutorial. So we're going to be looking at listing and review data within this sample Airbnb database. Now, our end goal is we want to be able to search for an Airbnb based on its name, but we also want to be able to look at the location data that's provided within these documents as well. So every single one of these documents has an address, and within that address object, we also have a location, which is going to be a set of coordinates with a longitude and a latitude. We're going to be using the longitude and latitude in combination with that name field. This is going to be a multi-part process. We're going to be creating a backend, which is going to consist of an API endpoint for communicating with MongoDB. We're going to have a front end for communicating to our backend, and then we're going to have a MongoDB Atlas search index. So all of these are going to work together to build us an autocomplete field that also searches on location. Now, before we get into the indexing side of things, let's go ahead and get started with our Node.js backend. So up on my screen, you'll notice that I have Visual Studio Code open. I have an empty project directory that just contains a backend directory and a front-end directory, both of which are empty. We're going to start with that backend directory. So what I'm going to do is I'm going to open up my command line. So what I'm going to do is I'm going to navigate into that backend directory. And I'm going to say npm init-y. And what that's going to do is it's going to create a package.json file for holding all of our project dependencies. Now, in terms of what our project dependencies should be, let's go ahead and install those right now. So we're going to say npm install, and we're going to say MongoDB, we're going to say express, and we're going to say course. So MongoDB is going to be our MongoDB Node.js driver. We're going to be building an API, so we're going to use Express because it makes things very easy for us. Now, because we're going to be using a front end and a back end, and they're both going to be served locally on my computer on different ports, we will need to worry about cross-origin resource sharing. So the easiest way to get beyond that is by installing this course package. Now, as far as development goes, we're going to install one more dependency just to make our lives a little easier when testing locally. So what I'm going to do is I'm going to say npm install nodemon. And this time around, I'm going to say --save dev. And what this is going to do is it's going to allow us to watch our project file and reboot our server every time a change happens. Now, before we start developing our actual application, let's go into that package.json file and create a new script for using nodemon. Inside of our script section, I'm going to say start, and I'm going to say nodemon, and I'm going to point it at a file that currently does not exist, but it will in just a moment. So I'm going to say main.js. Now back in my terminal, let's go ahead and say touch, and I'm going to say main.js. Now touch, all it does is creates a new empty file. You can create this main.js file inside of your backend directory however you feel the most comfortable. And now when we say npm start, it's going to say nodemon main.js for us. So let's go ahead and open up that main.js file. As of right now, it's empty. let's go ahead and start populating it based on the project dependencies that we had just installed. So I'm going to say constant, I'm going to say Mongo client, and I'm going to say equals require MongoDB. And the process is going to be the same for all of the other dependencies as well. With our project dependencies imported, let's go ahead and initialize the Express framework. With Express framework initialized, now what we can do is we can say that we want to use cores with Express framework. So we can say app.use cores. And this is just a very basic cores implementation, which will basically allow all operations from any ports that we want to use against our backend server. All right, so with Express framework initialized, let's go ahead and start listening for requests against our server. So we're going to say app.listen, and we're going to listen on port 3000 for this example, which is a common Node.js port. We're going to say async because we're going to be using promises, and we would rather use async and await operations. And we're going to say what we want to happen when we start up our server and start listening. So in this case, since we're using async, we should also have a try catch block in there. And if there was an error, we can say console.error and print out that exception. So inside of the try.catch block, this is where we want to establish our connection to MongoDB. Now, before we can establish our connection, we need to define our actual Atlas URI to connect to. And we can get that information from the MongoDB dashboard. So let's go ahead and go back into clusters. And let's say connect. Let's say connect your application. And we're going to be using Node.js, so let's go ahead and copy that connection string. I'm going to go back into Visual Studio Code. And outside of my listen, what I'm going to say is I'm going to say constant, and I'm going to say client equals new Mongo client. And I'm going to provide it that URI. So I'm going to paste it in. And we're not quite done yet. What we also want to do is we want to say unified topology. So this is an option that we can pass to the Mongo client. So we're going to say use unified topology, and we're going to say true. Now we can't just go ahead and use this new client as of now because we have a username and password that needs to be fulfilled in order to connect to any particular database or collection within our cluster. So let's go ahead and create a new username and password for this particular application. Let's go ahead and go back into our MongoDB Atlas dashboard. And what I'm going to do is I'm going to go to database access. I'm going to add a new database user. What I'm going to do for this user is I'm going to call it YouTube for the username. And for the password, I'm going to say password 1234. Instead of saying that I want to read and write to any database, which may be opening ourselves up to any kind of security risk, we want to give specific privileges for this particular application. We want to say that we want our username and password to only have read and write access to a particular database. And in this particular example, we want to give access only to the sample Airbnb database. Now, we could specify a collection as well. There's only one collection in this sample database, but we want this user to be able to access anything in regards to this database and only this database. Now, because this is an example, I'm going to make this also a temporary user, which will expire within 6 hours. So by the time that you watch this video, it will likely mean that my username and password no longer exists. But even if it did still exist, I do have a network rule applied, so that way only my IP address could connect to this particular cluster. With our username and password created, let's go back into our code. And instead of username, I'm going to call this YouTube. And for the password, I'm going to call this password 1234. And for the database is actually sample Airbnb. All right, so we have a client that should work as of now. Let's go ahead and connect to it. Let's go into our listen function, and let's say await, and let's say client.connect. Now, if there was no exception thrown, it means that we were probably successful. In addition to connecting to our cluster, we want to obtain the collection so that way we can use it inside of our API endpoint. Now, it's a good idea to actually establish that variable outside of the listen function, so that way it can be used within our endpoint functions. So let's go ahead and say var, let's say collection, and within our listen function, let's go ahead and say collection equals client.db sample Airbnb, and then dot collection. And our collection this time around is going to be listings and reviews. Let's go ahead and try running this application to make sure there's no errors. So what I'm going to say is I'm going to say npm start, which is going to use nodemon. So it ran, and it doesn't look like there were any errors. So it's going to be watching our application for any kind of changes that we apply as we go along with this tutorial. All right, so the next step. The next step is to actually create that API endpoint and perform our search. So we're going to get the foundation for this API endpoint applied, and then we're going to create our Atlas search index so that we can actually search against this particular collection. Now let's go ahead and below line 16 say app.post, and we're going to say that we want to do search is going to be our endpoint path, and we're going to say it's an async operation. And we're going to say request, response, and next, which is common Express framework boilerplate syntax. Since we're using async, what we should do is we should probably say try and catch. And if there was an exception, rather than printing it out, let's go ahead and say response.status. Let's go ahead and say that we want to apply a pretty generic 500 server error if there was a problem. And let's go ahead and send a message along with that error. We're going to say message, and we're going to say ex.message. Now, if there wasn't an exception, this is where we can actually query MongoDB. And in this case, for querying, we're actually going to be doing an Atlas search, which is going to be done inside of a MongoDB aggregation pipeline. So let's go ahead and add the boilerplate for this aggregation pipeline. Let's go ahead and say let result equals await collection.aggregate. Now, this is going to expect an array. And we're not going to populate it quite yet because we actually have to define our Atlas search index. Otherwise, we're not going to be successful. Now, the aggregate function is going to return an array. Now, what we can do is we can either use a cursor to iterate over the result set, or we can just convert it to an array and return everything. For simplicity, we're not going to be using a cursor for this example. So instead, we're going to say toArray. And what we're going to do with those results is we're going to send them back to the user. So we're going to say response.send result. And of course, this is not going to work because our pipeline is just an empty array. There are no stages in our pipeline as of now. So this is where we're going to end up going back into MongoDB Atlas to finish up our next step. So within MongoDB Atlas, go ahead and click on clusters. Let's go ahead and click on collections. And what we're going to do is instead of going inside of collections, we're going to click on the search tab. Now inside of the search tab, we want to create a new search index. So let's go ahead and click create. And we have two options. We can either use the visual editor or the JSON editor. In this example, we're going to be using the visual editor to get our job done. So let's go ahead and click next. For the index, let's go ahead and define what we want to call this index. It can be the default index. However, for this example, we're just going to call it autocomplete. It doesn't really matter what you call the index name. Now, for the particular database and collection, let's go ahead and find that sample Airbnb and click on listings and reviews. And what we're going to do is we're going to click next. Now we're not quite done yet. We actually want to refine our index so that way we can be prepared to not only use geospatial operators, but to use the autocomplete operator for text search as well. So let's go ahead and click on refine our index. Now, when refining our index, what we want to do is we want to add a field. For this particular field name, let's go ahead and name it name. So this is going to go alongside our actual Airbnb name field. So this is what we're actually going to type into our search box in hopes of retrieving results based on that name. So for example, if I start typing in apartment, I want all of the search results that kind of match the name apartment, depending on how I've decided to spell it. So let's go ahead and select a data type configuration for name. And for this particular data type, it's going to be autocomplete. Now we're not done yet. We want to add another field for our field mappings. So I'm going to say add field. So it's going to add another field option. So this time around, we're going to add the field address dot location. So remember, address is an actual object and location is inside of it. And that location has our latitude and longitude coordinates within it. So we're going to use address. For a geoWithin, so a geospatial operator, we cannot enable dynamic mapping. So we're going to disable it. Now for the data type, let's go ahead and instead of string, let's go ahead and choose geo. And before we finish things off here, we're going to scroll back up to the very top where it says dynamic mapping, and we're going to shut that off. So for this example, for this particular Atlas search index, we only have 2 fields within our document for this collection that an index is applying to. So our 2 fields that we can search on for this example are going to be name as well as address.location. If we try to search based on other paths within our document, it will not work because we have dynamic mapping off. So let's go ahead and save our changes. So it's going to ask us to confirm that everything looks correct. So yes, we have name, it's autocomplete. We have address.location, it's geo. Everything looks good for this example. And let's go ahead and say create search index. So it may take a minute or 2 to create that actual index. All right, so our index was created and there were 5,555 possible documents indexed. So something to note before we go ahead and start building our aggregation pipeline and trying to perform searches. So this Airbnb sample data set, it does not contain the entire scope of the actual Airbnb. In fact, it's not related at all. This is mock data. So when we plan to search based on location and text, our search results may not be 100% accurate because the data that's inside of MongoDB might not be 100% accurate. So let's give a specific example. I myself currently live in Tracy, California. If I were to do a search based on some kind of Airbnb listing in Tracy, California, nothing is going to come up because no records exist inside of MongoDB. So for this example, we will be doing a search based on a popular city like New York. But if your data set was more complete than the data set that I'm using right now, you'll get better results. So let's go back into our code editor. This is where we want to actually create the stages for this aggregation pipeline. So the first stage is going to be our search. Search always has to be the first stage in our aggregation pipeline. So this is going to be an object, and we're going to use the search operator. We're going to say that we want to use a particular index. This particular index, we named it autocomplete. Now this is where things get a little interesting. Rather than just doing an autocomplete stage or a geoWithin stage, we're going to be using the compound operator because we want both operators for the autocomplete and geoWithin to be used in a single operation or a single query. So to do that, what we're going to say is we're going to say compound. And compound has various terms that it allows. So for example, we're going to be using must. And must is basically saying that both of our conditions must be satisfied in order to return results. So the first condition, and this is must is actually an array. So let's go ahead and use it, must. This is an array. So everything inside of this array must be satisfied in order to return results. And in this case, it's only going to be two different operators. So the first operator that we're going to be using is autocomplete. So for the autocomplete operator, we're expecting a text query. Now, the text query is something that we're going to be passing in to this particular API endpoint. So let's go ahead and retrieve it from the API payload. So we're going to say request, we're going to say body, and we're going to say query. What we're also going to do is we're going to say that the path is going to be name because that's the field within our document. All right, so we have the autocomplete. Let's go ahead and move on to the next operator that must be satisfied. So we're going to create another object and we're going to say geoWithin. For the geoWithin, we have a few options. We can use a shape, or in this case, we're going to use a circle. So the circle says that we're going to provide it a center point and we're going to choose to search within a certain region or a certain radius from that center point. So we're going to say circle. We're going to say that the center is going to be of type point. And the coordinates are going to be a latitude and longitude. Now, when working with GeoJSON data, so this is what we're working with, GeoJSON, which is a flavor of JSON. It's still valid JSON. But when working with GeoJSON, the longitude is the first parameter in our coordinates. So it's longitude and then latitude. So it's something to keep in mind. So for the longitude, we're going to say request.body.position. longitude, or LNG. Now this is made up. We're going to be passing an object to our backend. The object, it really can be formatted however we want, but you'll see that when we actually use this object, this is the format that we're going to be using. So the latitude, we're going to say request.body.position.lat for latitude. Now, we're not quite done yet. We need to provide it a radius. So let's go ahead and provide a search radius. So we're going to say, for this example, we're going to say 10,000 meters. And we're also going to provide a path for our geoWithin. So we're going to say that the path is going to be address.location. So this should work. So if we provided a query and we provided a longitude and a latitude, it should be able to use this must compound operator to search for our text within our particular region. So instead of returning all results that might exist within our collection, it's going to return only results based on our text search criteria and within 10,000 meters of our provided location. So let's go ahead and give it a shot. What I'm going to do is I'm going to open up Postman. All right, within Postman, what I'm going to do is I'm going to say HTTP localhost port 3000/search. I'm going to switch this over to be a post request. For the body, we're going to pass it in a JSON body. So for the JSON body, it's going to be an object. And what we're going to do is we're going to provide a query. And in this case, I'm going to say apartment. And we're going to provide it an object, which is going to represent our position. So we're going to say position. And we're expecting to provide a longitude. And we're also expecting to provide a latitude. Now, I don't know longitude and latitudes off the top of my head. So what we're going to do is we're going to go into our web browser. And we're going to go to our friend Google here. And we're going to say latitude and longitude New York City. And we're going to copy that latitude and longitude. So I'm going to copy the latitude. And I'm going to go back to Postman. And I'm going to paste it in. I'm going to go back to my web browser and I'm going to copy that longitude. Now, because it's west and you have to understand longitude and latitude, west means that we're going to be using a negative number. So let's go ahead and go back into our Postman and let's go ahead and say that the longitude is going to be -74. Let's go ahead and send and see what kind of results that we get. So cannot read query of undefined. So there's a reason for this. If we go back into our code, the reason for this is we're trying to send a payload through a post request, and Express by default is not configured to handle payloads like that. So what we need to do is we need to change a configuration slightly. So up where we said we wanted to use cores, in addition to using cores, we also want to accept JSON payloads. So we're going to say app.use and we're going to say express.json. And we're going to save it. Now let's go back into Postman and see if that worked. I'm going to send. And this time around, it actually returned results. So in this case, it found something by the name of apartment in our search. And if we look at our address, which is somewhere in here, which we actually have a lot of data, which we're going to fix in just a moment. For our address, it actually says New York. So out of all of the data that could have existed inside of our sample Airbnb database, we got results from New York around apartment. And like I said, we have a lot of different results that came back in this search, or a lot of different fields, I should say. So let's go ahead and narrow it down. We probably don't want all of that data to be returned every time we do a search because it could become a little bit slow. So let's go ahead and make an adjustment. Let's go ahead and go back into our code and let's add another stage within our aggregation pipeline. So right now we're looking at one stage total. Even though that we have two different search operators, this is still a single stage because of our compound. So let's go ahead and add another stage. This time around, we're going to add a projection. So we're going to say project, and we're going to define only the fields that we want returned. So we're going to say name 1. So we want the name returned. We want the address returned. And we also want a special field to be returned based around search. So we want the score information returned. So let's go ahead and add score. Score is not part of our actual document. Score is a numeric value provided by our actual search. So let's go ahead and say meta, and let's go ahead and say search score. And I'm going to save it. And let's go ahead and try to run it again. Let's go ahead and say send. This time around, it returned the ID because if you don't specify not returning it, it's going to return it. It returned the name, and it returned an address, and it returned our score. So using the score information, we can actually determine how close of a match our data was based on the geographical coordinate as well as the search term. And this could be valuable when designing your own application because it may be something that you can sort on or do some kind of calculation on. All right, so we have specific search results returning. This is fantastic. The next thing that we want to do is we want to create our front end. So we have a backend. Our backend, we're allowing it to submit post requests to the search endpoint, and we're doing our search based on a geoWithin as well as an autocomplete. And we're providing only fields that we want specifically returned with our results. So this time around, what we're going to do is I'm going to open up another command line instance, and I'm going to navigate into our front end directory. Now, within the front end directory, I'm going to create a new file. I'm going to create a file called index.html. Now, like I said, if you don't have touch or you're not comfortable with creating files through the command line, just go ahead and create an index file in that front end directory, however you feel the most comfortable. So we're going to open up this index.html file. As of right now, it is empty. So what I'm going to do is I'm going to add some boilerplate HTML code to get us started. All right, so I have some very basic HTML boilerplate. So for this, there's a million different ways to do an autocomplete search in a front end. For this, we're going to be actually using jQuery because it makes it very easy for this particular example. Now, it's up to you if you want to use this in your own production application. So for this, what we're going to be doing is we're going to be using jQuery UI. So let's go back into our web browser, and you'll notice that I have it up on my screen. So this is jQuery UI. It's kind of an extension to the regular jQuery library, and it does have an autocomplete functionality. Now, rather than downloading it and adding it as part of our project, we're just going to use a CDN for this. So I have a jQuery CDN up. It's part of what jQuery offers. And what I'm going to do is I'm going to use the latest, which is 1.12, and I am going to copy a link to the theme. I'm going to go back into my Visual Studio Code editor. And what I'm going to say is I'm going to say this is going to be a CSS link. So I'm going to say it's going to be relationship style sheet. And the reference point is going to be that link that I just copied. What I also need to do is I also need to copy the minified JavaScript. So what I'm going to say is I'm going to copy the link. I'm going to go back into my code, and I'm going to say script, and I'm going to provide it a source, which in this case, the source is going to be the link that I had just copied. But jQuery UI does have a dependency of the regular jQuery. So what I'm going to do is I'm going to copy one more URL. This is going to be part of regular jQuery core, and I am going to copy the minified link, and I'm going to go back into Visual Studio Code, and I'm going to paste it in. So we should be good to go. We have our jQuery dependencies as of right now. Now, before we start actually writing our logic, let's go ahead and create our HTML form element, which will be our autocomplete text input. What we're going to do is we're going to wrap it in a UI widget because this is what jQuery UI expects. So we're going to say div, we're going to say class equals UI widget. And inside of it, we're going to have a label. So we're going to say label, and this is going to be 4. I'm just going to call it B&B. And it really doesn't matter what you call it. But for this, we're going to say maybe something like bed and breakfast. And let's go ahead and provide it a latitude and longitude inside that box so we know what we're searching on. So if I open up Postman, I have a longitude right here, which I'm going to paste in. It's really not going to do anything for us other than remind us that we are searching against those coordinates. Because for this example, I am not going to let the user specify their location. We're going to assume that the web browser picked it up or something similar. So we have the label. Let's go ahead and create our form element. So we're going to say input. We're going to say ID equals BMB. And the name for this ID is actually very important because we're going to be using it inside of our script down here. So inside of our script, what we want to do is we want to remove this comment, and we want to say something along the lines of document. And we want to say whenever this document is ready. And when it's ready, then we can actually start applying our autocomplete. So let's go ahead and say the following. So let's go ahead and say $, hashtag BMB dot autocomplete. And when we say autocomplete, we're going to provide it some options here. So the first option is going to be our source. So this is a field. And for our source, this is going to be an asynchronous function. And it's going to have a request and a response. All right, so let's go ahead and work with that information. Let's go ahead and say let data equals await, because this is asynchronous. We're going to make an HTTP request against our API endpoint. We're going to just use a simple fetch. So this fetch, let's go ahead and say HTTP localhost port 3000 and then search. And we're also going to need to provide it a payload because this is a post request. So we're going to say an object here. We're going to say that the method is going to be post. We're going to say that the headers, because by default it's not going to be application JSON formatted, we're going to say content type. We're going to say application JSON. And now that we're done with the headers, we can actually define the body that we want to send. So let's go ahead and say body. It's expecting that we send a string, but we know that on the receiving end, because we're saying application JSON, which I've seemed to have misspelled here, it's gonna parse out the string that we provide. So we're gonna say JSON.stringify. So we're gonna stringify an object, which the backend is going to make sense of, and we're gonna provide it what we provided Postman. So we're gonna say query. For the query, it's going to be whatever the user types into the field, and jQuery UI does have its own expectations, but we're gonna say request.term. So this is going to be the term that's entered into that field. And then we have a position. And for the position, it is an object. We're providing it a longitude, which I can copy from line 10. And then we have a latitude, which I'm also going to copy from line 10. So this is for New York. Remember, we're hard coding this. But in your application scenario, maybe you're looking at the browser's location or the mobile phone location, or who knows, however you're receiving that particular latitude and longitude information to better optimize your search. We're just hard coding it as New York for this example. So we have the request, so this fetch. When it comes to this data, we actually want to format it so that way jQuery UI and autocomplete can make sense of it. So to do that, because we're using fetch, let's go ahead and use then, and let's go ahead and say results.json. And then we're going to say, and let's drop this down so that way it's a little easier to read. We're going to say then, and we're going to say results, and we're going to say results.map result. And this is where we actually start doing our formatting. So for our formatting, let's go ahead and say return. And we're going to return an object, and this is an object that jQuery UI is going to expect. So it's going to expect a label, it's going to expect a value, and it's going to expect an ID, all of which is information that we actually have within our document. So let's go ahead and return that object. This object is going to have a label. So the label information is going to be the result.name. So this is what we see as we're doing the autocomplete. We have the value, which is going to be what we see when we actually select a value from the autocomplete. So in this case, we're also going to call that result.name. And then for the ID, this is going to be the ID of the particular piece of information. So in this case, for an ID, it makes sense to use our actual document ID. So we're going to say result._ID. Now, to finish things off, now that we have essentially our data, what we want to do is we want to return it. So we're going to say response data. Now let's go ahead and further add options to this autocomplete, because if we left it alone right now, every character that we input into our search box is going to be an API request, which may be a little aggressive. So instead, let's go ahead and say that we want the minimum length to be 2 characters. So after the user has entered 2 characters in, then the autocomplete will kick in and start making requests. And even 2 is a little aggressive. We probably want to, in reality, depending on our data set, probably limit that to maybe 5, but it really depends on the data set. So for this example, 2 is fine. And ideally, if we wanted to, we would also have a select. So the select is what happens after you select an element from our autocomplete results. Now, we aren't going to be using this for this example, but I'm just going to write it out so that way you know what it looks like. This won't stop us from being able to use our application. It's only going to stop us from furthering our logic if we select an item that comes back in our result set. So let's go ahead and try it out. We are already running our backend because we're using nodemon. Now, for our front end, we should be serving it. Now, we can actually serve it with Python, or we can use some other serving mechanism. I'm actually using a package called serve. It's part of npm. You can actually get it by saying npm install -g serve, but that's up to you. It's totally up to you what you want to use to serve your front end. I'm going to be using serve though. So what's happening is I'm serving my application on port 5000 now. So this is my front end application, and my back end is being served on port 3000. So let's go to our web browser. Let's go ahead and say localhost 5000. So you'll notice that I have a search box here, and I'll zoom in. Let's go ahead and start searching. I'm going to say apartment. And you'll notice that as I enter stuff into the search, my results are slightly changing. So I'm going to say apartment with, and it's going to pick up results based on whatever I type. And in this case, it's going to be in New York because that was my latitude and longitude coordinates. So again, this is different from the other example that I had given previously, where we had just used the autocomplete functionality, the autocomplete operator, which is going to search across our entire collection. This is searching across our collection for whatever we type in this field, as well as our geocoordinates, because we're using geoWithin, using that compound operator within our aggregation pipeline. So you just saw how to use the compound operator within Atlas Search. So in this particular example, we did an autocomplete text search where the user provided input, but we also used the geoWithin operator, so that way we were able to also search within a particular geographic region as well. So this is useful if you want to compound various operators in a single operation within your aggregation pipeline. If you found this video useful, it would mean a lot to me if you gave it a thumbs up. And then if you had any questions about it, you can either drop a comment in the YouTube comment section, or better yet, go to the MongoDB community forums. It's community.mongodb.com. Start a new thread, talk about this video. You can even tag me in it if you need specific help regarding the video as well. Until next time, everyone.